Hi everyone, I'm Josia, the programmer of Cats Organized Neatly, which is a puzzle game about organizing a bunch of cats neatly on a grid. Today I'm going to show you how you can make a similar game yourself. First, we're going to learn how to make pieces that we can drag around and rotate. Then we'll add a grid, some rules for how pieces can be placed, and a win condition that will allow us to move on to the next level. Finally, we'll give our game a little polish by making the pieces move and rotate smoothly. We'll get started with a new project with only some sprites already imported, and a room with nothing but a background in it. If you want to follow along, you can find a link to download this project in the video description. By the way, if your GameMaker looks a little different than mine, that's because I'm using the code editor too. You can enable it in the preferences under code editor too. Just check this box and restart GameMaker and you're good to go. First up, let's create a new object. We'll call it Object Piece. We'll also assign it one of our cat sprites. We'll add a create event, which will get called once when our object is created. So it's the perfect place to initialize variables. Let's add one called drag, which we'll use to keep track of whether or not the piece is currently being dragged. In the mouse left pressed event, we will set this variable to true, so the piece knows it's being dragged when we click on it. In the mouse left released event, if it's currently true, we'll set it back to false, so dragging stops once we let go of the mouse button. The step event gets continuously called every frame of the game, so it's great for updating our piece's position. We'll tell it to move to our mouse position if it's currently being dragged. We also want to be able to rotate our piece with the right mouse button, so we'll add a right pressed event. Here, we'll once again check if the piece is currently being dragged, and if so, increase its image angle by 90. Since we want to have a bunch of different cats of all shapes and sizes, let's create another object, assign it a different cat sprite, and set our piece object as its parent. Doing this will copy all of its events and even update them automatically whenever we make changes to the parent object. Alright, let's quickly create a third object for good measure, and then let's add a bunch of the three objects to our room. Starting the game now, we can already drag and rotate our cats around. However, you'll notice that the cats aren't drawn in the correct order yet. Per default, whichever instance was created last will also be drawn last. In our case, we want whichever cat we're currently dragging to always appear above all other cats. To do this, let's set up different layers in our room. First, let's rename the default instance layer with our pieces on it to Pieces, and then let's add another layer above it called Piece Dragged. Now, whenever we start dragging a piece, we'll want to move it to the Piece Dragged layer, and once we drop it, we'll move it back to the Pieces layer. To do that, let's go to the mouse left pressed event in our object piece and change its layer. We'll use layer get ID to find the layer with the name Piece Dragged. In the mouse left released event, we'll reset the layer to Pieces. Now, as you can see, the cat we're currently dragging will be drawn above all the others. Next up, let's add a grid. We'll create a new object called Object Tile and assign it the tile sprite. In our room, we'll add a new layer called Tiles, which we'll place below our Pieces layer. Now we'll use a bunch of the tile objects to make a grid area in our room. For easy placement, be sure to enable the room's grid function and set the grid size to 64, which is the size of a single tile sprite. You can hold the Alt key and click-drag your mouse to place multiple instances at once. Next up, we'll want our pieces to actually snap to the grid. So let's create a new script in which we initialize a global variable called grid size. We'll set it to 64 as well. Then let's go back to our piece object's step event. An easy formula to snap our coordinates to the grid is by dividing them by our grid size, then rounding the result to a whole number using the round function, and finally multiplying by our grid size again. We'll do this for both x and y position. Since we only want our pieces to snap while on the designated grid area, we'll add a condition to check if the piece is currently colliding with any tile objects using place meeting. Starting the game, we can see that our pieces now snap to the grid. Except there's a problem. Only one of the cat shapes snaps to the correct position. The other ones snap to a position between tiles. To fix this, we need to adjust the sprite origin of these pieces. The origin is the point of a sprite that corresponds with its position in the room. So, for example, when we move our pieces around with the mouse, The origin will be the exact point that will be placed at the mouse position. It's also the point that the sprite rotates around. You can change the origin to a couple of default positions like the sprite's center or corners, directly drag it around with your mouse, or type in its coordinates. When importing sprites into a project, setting their origins to be in the middle center is usually a good choice, especially when working with rotating sprites. However, our cat shapes essentially consist of a bunch of 64 by 64 pixel cells. Since we want these cells to align with our grid, we need to make sure the sprite origin is in the center of one of them, and not necessarily in the center of the sprite. So we'll set the origin for this sprite to 9696 and the other one to 3296. And as you can see, they now snap to the correct positions on the grid. Next, let's implement some restrictions on where we are allowed to place our cats. As you can see, we can currently place them on top of each other, which shouldn't be allowed. So let's go to our mouse left released event and add a condition to see if our piece is currently colliding with any other pieces when we drop it. If it is, let's reset this piece's position to X start and Y start. If we try to place a piece on top of another now, it will jump back to the position it originally had when being created. But, as you can see, the collision detection is not very accurate yet. Some cats will block more tiles than they should. To fix this, we'll have to have a look at our collision masks. Per default, new sprites will use a rectangular collision mask. But since most of our pieces aren't rectangular, you can see that the mask covers areas that should be free. Now, there are two solutions to this problem. The easiest one would be to just set our collision mask type to precise. As you can see, this limits the mask to only the area of the sprite with opaque pixels in it. While this method will work, you'll have to be extremely careful when creating your sprites, since you have to strictly stay within the desired collision shape. Even a single stray pixel could ruin the collision mask. Luckily, there's another option. To give us a little more flexibility, we can use separate sprites as our collision masks. We'll use a sprite of a simplified shape with its collision mask type set to precise and assign it as the mask of the corresponding piece object. Then we'll do the same for the other two shapes. Don't forget that each of the mask sprites needs to have its origin at the same position as its counterpart. As you can see, we can now neatly snuggle the cats next to each other. Another thing we want to prevent is being able to place our pieces in awkward positions that are only partially on the grid. To do that, let's add a new object called Object Blocker and assign it sprite. Let's uncheck the visible box in the object so it does not get drawn in the game and will only be visible when placed in the room editor. We'll use this blocker to designate areas where no pieces can be placed. For our first level, let's just put a border of blockers around our grid. Then let's go back to the mouse left released event of our piece and extend our collision check. The two vertical bars function as an OR operator, meaning that the condition will check for a collision with other cat pieces or blocker objects, and if either of them is true, it will reset the piece's position. Starting the game now, we'll see that we can no longer place pieces on the edge of the grid. Next, let's add a button that will allow us to progress between levels. We'll create a new object which we'll call Object Button Next, assign it sprite, and add it to a new layer in the room. In its mouse left pressed event, we'll add a simple if statement. If we are not in the last room of the game yet, we want to move on to the next room. If we are in the last room already, that means we've beaten the game, so in this case we'll just end the game instead. We also want our button to be highlighted when we hover over it. The button sprite has a second frame for this. We'll add a mouse enter event which gets called when we hover over the object with our mouse. Here we'll change its image index to 1, which will switch it to the highlighted frame. Then we'll add a mouse leave event in which we set its image index back to 0. To see if our button actually works, we'll have to create a second level first. So let's duplicate our existing room and make some changes to it. We'll remove some tiles from the grid and place blockers there instead. And we'll replace some of the cats with different ones. Starting the game now, we'll see that clicking the button brings us to the next level, and clicking it again will end the game. Now all that we need for this to be a functional game is a win condition. Let's go to our script and create a new global variable called levelSolved and a new function called checkIfSolved. Now, depending on what kind of game you're trying to make, the conditions for solving a puzzle could vary vastly. Luckily, for Cats Organized Neatly, our win condition is extremely simple. The level is solved once every cat is placed on the grid. So our win condition function will work as follows. We will start by assuming the level is solved. Then cycle through all of the cats in the level, checking if they are on the grid or not. If we find any that isn't on the grid, we'll know the level isn't solved yet. So, let's start by setting level solved to true. Then, let's add a with statement. This will allow us to run code from every instance of an object. So, if we write with object piece, whatever we put in the curly brackets behind it will be done by every instance of object piece currently in the room. In here, we will use place meeting to check if each of the cats is not on the grid. If it isn't, we will set level solved to false. Now that we have our win condition set up, let's go back into our object piece and implement it. Technically, we could run check if solved every frame, but that would mean a lot of unnecessary processing. Instead, we will only perform the check whenever we drop a piece in a new position. So, let's go to the mouse left released event and add our new function in here. Then we'll add a condition to the mouse left pressed event of our object button so that it will only move on to the next level if the current level is solved. We'll also reset level solved back to false when moving to a new room. Let's add a draw event. Here we can tell the object what it should draw to the screen. Draw self will draw the object with its current properties, and if we add an if statement, the button will only be visible once the level has been solved. Starting the game now, you'll see that the button appears once we've placed all cats on the grid. Now that we have all functionality implemented into our game, it's finally time to add some polish. An easy way to make your game look more pleasant is by making objects move around smoothly. To do that, we'll make our pieces follow the mouse using a lerp function. That means pieces won't immediately jump all the way to the mouse position every step, but instead only move towards it part of the way, resulting in a more visually pleasing motion. Now, we could go about this by implementing lerp into our movement functions directly, which would look something like this. But this would only work in very limited cases. It would get more complicated if we tried to combine it with snapping to the grid, and could lead to all sorts of unforeseen problems with collision detection later down the line. So, a good trick to use whenever you want something to appear like it's moving smoothly, without messing with the movement code itself, is separating its actual position from the position it's drawn at. Let me show you what I mean. We'll go into our object piece create event and initialize two more variables called xDraw and yDraw. Then we'll add a draw event in which we'll add a draw sprite x function. This will tell our piece to draw itself with all its current properties. Except, instead of putting x and y as the position, we'll use our new xDraw and yDraw. This way, we can now go into the step event and update our piece's draw position independently from its actual position. For example, if we just set xDraw to x and yDraw to y directly, things would look exactly as they did before. But since we want to implement a lerp function here, let's have a look at how to do that. The first argument of our lerp function will be our current draw position. The second argument will be our target position, which is x. And the third will be how quickly we want draw x to move towards x. We'll add a new variable called lerp position here, so we can later try out different values. Then we'll use the exact same function to lerp our yDraw as well. Now, to easily adjust our new lerp position variable, let's add it to the object's instance variables. We can use the range checkbox in the options to change its value with a slider. Let's test how different values affect the movement of the pieces. If we put lerp position at 0, our piece will move 0% of the way towards our mouse position each step, which means it won't appear to move at all. If we put it at 1, it will move 100% of the way towards our mouse, which essentially looks the same as what our movement was before. So, the sweet spot is somewhere in between. The higher our lerp position is, the more immediately the piece will follow our mouse. Personally, I like a value of 0.3 because it looks quite smooth without being too sluggish. Now that we know how to make values lerp, we can use the same technique to make our piece's rotation look smoother too. Let's add another variable to adjust how fast we want our angle to lerp. Then let's add an angle draw variable to the create event. In the draw event, we'll change the angle to draw our sprite in to the angle draw variable. And finally, let's lerp this new variable towards our current image angle in the step event. And just like that, our cats turn around a lot more pleasantly. As you can see, lerp is a powerful tool that you can use to easily make your game look a lot more polished. And that's it. Just like that, we made a little grid puzzle game. You can find a link to download the finished project in the video description. Thanks for watching, be sure to subscribe for more tutorials, and happy game making!